I was lucky enough to serve as an aquanaut on an underwater mission before I was even an astronaut, and that was when I was working at NASA as a scientist, supporting life science experiments like the ones that Drew and I are involved in up here now. As an aquanaut crew member, we were down there using it as an analog, so trying to understand more about what it's like to do missions and prepare for missions up in space by using an environment or a structure like that underwater, which has several elements in line with the space station. It's an isolation, you need a life support system to go outside, and of course it's totally different there because it's water. Still, you can't go outside in the water and survive without this life support system for very long either. The other answer, I do miss being underwater. I love swimming, I love scuba diving, I love being in the ocean. And it's very different up here. You know, I think about those things, it would be wonderful to do them, but I guess I don't really miss anything up here. I think it's because we're in this new environment. Floating around is actually a little bit like swimming. And so we go outside in the spacesuits too, a little bit like the stuff that we do underwater when we train at NASA. So there are a lot of parallels up here, and it's a lot of fun to swim and scuba dive. It's also a lot of fun to be floating around up here like you do.
Floating around as a kid, and they were all wonderful schools, and it taught me to be adaptable as I moved from school to school. Then I went to college at the U.S. Military Academy at West Point, and that was where I made the decision to serve my country. From there, I went to medical school at the Uniformed Services University of Health Sciences in Bethesda, Maryland, which is a medical school to create medical officers for service in the military. And that taught me to serve my patients. So throughout my career, my education has been focused on service to my country, service to my patients, service to humankind now as part of the space program.
We will organize missions allowing access to capabilities of machines which allow people to live for long periods of time on the moon, like the Martian. You just have the same way you want or does microgravity technology?
And many of those things that we see today that we take for granted, developments in wireless technology, developments in solar power, even the way that we provide food and water to astronauts, how we purify the water that we drink, how we prepare our food, how we were able to scrub their air, keep the air clean for them. In the same way, when we undertake this journey as part of the Artemis program to return to the moon and then continue on to Mars, it's going to catalyze all sorts of new technology development that will inevitably have spin-offs that will extend into daily life, improving life for all of you and all of us on Earth. And the musical instrument here. One of the things we like to do in our free time is take pictures of the Earth and look at the size of the lens on this camera. It's a big one. It's a 400 millimeter and allows us to take close-up photos. I actually tweeted out a photo today of the Victor Valley that I was using this exact lens here. So of your community there with a camera just like this out the window of the space station.
Well, the difference in running in those different environments really comes down to the gravity situation. So 1G on Earth, up here we have microgravity, or really no gravity pulling us down, and then on the moon we have about 1/6 of the gravity. So what that means is that here on the space station you can't really run. Here's what happens if you try to run when you're just standing, you're not going to be going anywhere because gravity's not pulling you down. But we actually do run as part of our exercise up here. In order to do that, we have a treadmill, just comparable to one that you might have on the Earth. But we need to have a way to pull ourselves down onto the treadmill, otherwise we would just fly up all the time. So we actually wear a harness and then these attached bungees to pull us down onto the surface of the treadmill. And then we can run actually quite a bit faster. I can run quite a bit faster up here because I don't actually pull myself down to my full weight. It's a little bit uncomfortable with the harness that we wear if you do that. So I run at about 70% of my body weight, which means I can run faster up here than I can on Earth. On the moon, with only 1/6 gravity, I would be able to run probably faster. It would be a much different way of running, though. You've probably seen some images of the Apollo astronauts kind of bounding along, but I think that I would probably be faster up there because you can cover a lot of ground with while expending less.
Living and working on an international space station. Thank you.
Thank you to all participants from Rancho Verde Elementary. Station standby for conference for announcements.